Let's be clear, Java development is neither trendy nor exciting. Making videos about Go and Rust would definitely be more successful on YouTube, but I stubbornly insist on discussing Java on this channel because I strongly believe that Java has some advantages very few other languages can realistically claim. So in this Monday morning review, we'll discuss the real benefits of knowing an established, mature ecosystem and why longevity in software often beats novelty. First of all, you are guaranteed to find Java at the top of any dev survey, year after year, regardless of how many Java killers come and go. And yes, while JavaScript is usually taking the first place in these surveys, the comparison is not fair because JS is the only language people are actually forced to use when building for the browser. But when it comes to backend languages, Java is still by far the most consistently used option in large, real-world systems. Most big tech companies use it to some extent, and Java is even behind some of the biggest games in the world. But Java's wide adoption is also its biggest liability because in enterprise software, backwards compatibility is a must. And this brings us to the topic I want to discuss today. After 22 years, Java just announced that they are planning to add null safety inside the language. To be fair, null safety might seem a trivial problem since so many modern languages baked it in from the start. It is long accepted that this is a major design flaw in modern software development, and even Tony Hoare, the man who invented the null reference, famously called it his billion-dollar mistake. But for a language like Java with production codebases spanning over multiple decades, baking in a null-safe type system is a really complex and interesting problem. For a bit of context, there are a few widely accepted approaches when it comes to modern null safety. Go, for example, avoids null pointers in most cases by pushing you to use concrete zero values and explicit error handling. Instead of returning null, you typically return a value and an error, forcing the caller to check the outcome. There's still a concept of nil, especially with interfaces and pointers, but it's managed in a way that keeps things predictable and explicit. Rust takes a much stricter stance, and it doesn't have null at all. Instead, it uses the option type to represent a value that may or may not be present. If a function might not return a value, it returns option, and you have to handle both the some and none cases explicitly. The compiler will not let you ignore it, and you can't just pretend it's not there and hope for the best. Back to the JVM, Kotlin took a different path. Kotlin made nullability a first-class citizen of its type system, and, honestly, it's one of the main reasons many teams migrated away from Java in the first place. But, of course, Java can't simply copy this implementation because Kotlin had the luxury of starting from scratch. If Java suddenly made all types non-nullable by default, the ecosystem would implode. Libraries would break, and all the enterprise systems that depend on things not changing would be left hanging. So, how do you fix a 30-year-old foundation without knocking the house down? The answer lies in the ongoing work of Project Valhalla. Instead of a blanket change, Java is introducing null-restricted value types. The goal isn't to banish null entirely, because that ship has sailed back in 1995. The goal is to allow developers to opt into safety where it matters most. The proposed transition is actually pretty straightforward. First, the language has to move away from the everything is an identity object model so that it can create types that behave more like primitives. Second, you might soon see bang syntax in Java. Of course, this tells the compiler and the JVM that this specific variable is restricted and can never ever hold a null reference. Then, because the JVM knows a value can't be null, it can stop performing null checks under the hood and flatten that data in memory, giving us a massive performance boost as a side effect. But what's more interesting is Project Valhalla itself, which is essentially trying to bridge the gap between the high-level abstraction of object-oriented programming and the low-level efficiency of hardware. The primary focus is to augment the Java model with value objects and user-defined primitive types, while also adding major enhancements to Java generics. For years, Java developers were forced to live with a trade-off. They could either use primitives, which are incredibly fast because they are stored directly as values, or they had to use objects, which are much more flexible but come with a memory tax. Every object in Java has a header and an identity and requires a pointer. This means that when you are iterating over an array of objects, the CPU is constantly chasing pointers all over your RAM. This is the pointer chasing problem, and it is the silent killer of modern performance. Project Valhalla introduces the concept of value objects that code like a class but work like an integer. In practice, imagine we have a city record with an integer value for population, and we have to calculate the total population of a country. You'd probably be surprised to find out that accessing the population values through a simple array is more efficient than iterating over the list of cities and getting the population from an accessor. Sure, the difference is insignificant in large projects where you are interacting with the database or waiting for network responses. But in high-performance computing, financial systems, or game engines, these micro-inefficiencies aggregate into a massive bottleneck. So thanks to the efforts in Project Valhalla, you will be able to add the value keyword and the bang operator to the record, essentially telling JVM that it doesn't need to reserve space for a null state, and it doesn't need to give these objects a unique identity. Because of this, the JVM can flatten the array, so the population integers will be sitting right next to each other in memory. Your CPU doesn't have to jump anywhere, and it just streams the data in a straight line. This is exactly how C++ or Rust handles structs, and it's why those languages have traditionally dominated low-latency fields. But remember that the structure is still a Java record. You still have your constructors, your methods, and your type safety, so you haven't sacrificed the powers of Java to get the performance of C. And this leads us to the final piece of the Valhalla puzzle, generic specialization. Historically, you couldn't have a list of primitive int values. You were forced to use an array of integers, which boxed every number into an object, reintroducing all that pointer chasing we want to avoid. Again, this was a constraint required to ensure backwards compatibility. Back in 2004, when generics were added to Java 5, the architects had to make sure that new generic code could still talk to old raw code. Their solution was to erase the type information at compile time and treat everything as a generic object. Since a primitive int isn't an object, the JVM has to box it into an integer wrap. So, basically, when you have a list of integers in Java, you aren't storing numbers, you are storing a list of pointers to objects that contain numbers. This is where the performance dies. To fix this, Project Valhalla introduces universal generics, which means that instead of erasing everything to object, the JVM becomes template-aware. So when you write this list, the JVM won't just erase the point to a generic object reference. Instead, it will specialize the class. In other words, it generates a custom version of ArrayList specifically for the layout of your point value record. But you might be wondering, why worry with all these implementation details when you could simply pick a newer language and stick with that? After all, there are a lot of people who are migrating to Kotlin or Go. Well, the answer is simple. The job market doesn't care about what's cool on GitHub. When you look at the architecture of the world's most profitable industries like banking, insurance, logistics, and retail, more often than not, you'll find out that they run on Java. In banking alone, over 90% of Fortune 500 companies still rely on Java to process trillions of dollars every single day. And sure, people are building new programming languages, but here is your awesome trivia for the day. In a recent interview for GitHub, the language architect for Turbo Pascal, C# and TypeScript discusses the complexity of creating a new programming language in the modern world. His message is very straightforward. You can design the most elegant, most perfect language in the world, but if you don't have 20 years of libraries, millions of lines of proven code, and a massive community of developers who already know how to use it, you're starting at a massive disadvantage. Even hip new languages like Rust or Elixir are actually close to 15 years old now, and their adoption rate is almost zero compared to the established players. So if you want to make a pragmatic decision for your future, it is always better to double down on the technologies that already run the world's infrastructure, rather than chasing whatever trend happens to dominate the YouTube trends this month. If you like this video, you should consider joining our community where I'm posting more dedicated content. Please don't forget to smash all the buttons, and until next time, thank you for watching.